Today's most cutting-edge aircraft could never perform their missions without the aid of the mammoth refuelers. For many combat aircraft, a tanker is an oasis in the sky. Often overlooked, these unarmed warriors perform the vital mission of supplying planes with extra fuel to complete their strikes, turning short-range aircraft into global attackers. In 1990, Iraqi forces under the command of Saddam Hussein pushed across the southern border and into neighboring Kuwait. The act galvanized the international community and triggered a massive buildup of Allied forces in the Persian Gulf. It was one of the fastest and largest mobilizations in history. 31 countries sent over 500,000 troops.
Stabilize it, Bill, for a little bit. Punch it on up.
Departure Gulf 35 out of 1,000 for 4,000. Gulf 35, direct radar, clear to climb on course. Gulf 35, traffic 1 o'clock, 22 miles northwestbound, and level file 60. Gulf 35.
More than 3,000 aircraft stood ready on carriers and at bases in Saudi Arabia. By Christmas, the Middle East bristled with weaponry. The air power advantage clearly belonged to the Allies. But of all the warplanes that flew over the desert, one of the most valuable didn't carry any weapons at all.
No, I've got 3 of them, 2 on the coast side, 1 in the middle. Okay.
The humble tankers, the giant flying gas stations like KC-10s and KC-135s, help make some of the most decisive strikes possible. By quenching the thirst of aircraft from every service and almost every Allied nation, refuelers extended fighters' range and quickened their attacks. With their help, the war in the Gulf lasted just 43 days. Today, this aerial waltz is routine. In-flight refueling is now a standard aspect of any military operation. But it wasn't always this easy. Safely connecting 2 planes high above the Earth took many years of practice. Just 11 years after the Wright brothers' first flight, airplanes were taken into combat for the first time. Although most were used as scouts, it wasn't long before they took on a more active role. The first attempt at aerial refueling came in 1921 with a young barnstormer named Wesley May. He took the direct approach and actually carried the fuel by hand to the other plane. Although his stunt was certainly entertaining, it was hardly practical. Two years later, at an air base near San Diego, California, 2 military aviators set out to develop a more sophisticated method of in-flight refueling. Using a simple hose and cable system, Captain Lowell Smith and Lieutenant John Richter refueled their de Havilland DH-4 biplane twice and managed to keep it in the air for more than 37 hours. Endurance flying captured the public's imagination and encouraged people from all walks of life to take to the air. Every day, there were new aviators making new records. The press could hardly keep up. In 1928, Commander Carl Spaatz and his crew of 4 set off in their Fokker trimotor named the Question Mark. The question was how long they would be able to stay in the air. While in flight, they were refueled 43 times by a single-engine Douglas biplane. Spaatz and his team managed to stay in the air for 6.5 days straight. They were greeted as heroes. In nearly a week, the plane had flown 11,000 miles and had taken on board not just fuel, but also oil, food, batteries, and supplies from the Douglas biplane. They had proved that aerial refueling could be carried out safely and easily by day or night, and that the only limitations on how long a plane could stay in the air were the reliability of the aircraft and the stamina of the pilot. Surprisingly, little application was found for aerial refueling in the 20s, and even military strategists saw it as little more than a good test for engine reliability. But their lack of enthusiasm didn't keep anyone from trying to go even further. In 1930, having been criticized by the press as having nothing better to do, John and Kenneth Hunter used refueling techniques to stay in the air for an incredible 553 hours. That's 23 days. Having suffered a bad oil leak, the crew eventually came back down to earth, looking a little scruffy, but certainly no worse for the wear. By all accounts, in-flight refueling was easy and reliable. All over the world, people used the technique to fly farther than anyone thought possible. Surprisingly, even the onset of war did little to spur refueling development. Although the British did conduct limited experiments, military planners weren't interested. The job of maintaining air superiority fell to the bombers, and most of them already had the range to get to any target in Europe or Asia. The range of fighters, however, was still lacking. For most of World War II, fighter escorts had to turn back to base well before the bombers reached their targets. Refueling in flight was simply not an option. It wasn't until the Americans introduced their long-range Mustangs that bomber crews finally had adequate protection behind enemy lines. For the true value of aerial refueling to come to light, it would take a new kind of plane and a new kind of war. Even before the dust of World War II settled, the dawn of the Cold War began. The use of nuclear power changed everything. Suddenly there were new enemies and new weapons, and both were so powerful that it was hard to know what to do with either. After witnessing the horror and devastation in Hiroshima and Nagasaki, few people wanted to use nuclear weapons again. But at the same time, no one wanted to be threatened by them either. The result was a policy of deterrence, to show force without using force. The cornerstone of this new policy was the Strategic Air Command, or SAC. Established in 1946, SAC was designed to demonstrate America's ability to carry out offensive and defensive operations around the world. Namely, the ability to drop nuclear bombs anywhere, anytime. To carry out this kind of mission, SAC would need a fleet of high-performance, long-range bombers. And for the first time, the necessity of aerial refueling was apparent. The first member of the Strategic Air Command fleet was the Boeing B-29. Having performed brilliantly in the Pacific during World War II, The B-29 was prized for its speed, firepower, and most importantly, its range. 3 months after the formation of SAC, the United States staged its first demonstration of global nuclear air power. On July 1st, 1946, a SAC B-29 dropped a nuclear bomb on the Bikini Islands. Within 2 years, SAC's B-29s were joined by Boeing B-50s and Convair B-36s. Both aircraft were incredibly powerful. In fact, the B-36 had such immense range that it was almost capable of being an intercontinental bomber. Although these piston-powered bombers remained vital to SAC's plans, piston-powered fighters did not. The jet age had dawned, and the Strategic Air Command was anxious to incorporate the new technology into its fleet. When SAC was formed, it enlisted the service of 2 of the longest-range fighters ever built, the P-47 Thunderbolt and the P-51 Mustang. It was hoped that these veterans, unrivaled in war, could perform with the addition of a completely different powerhouse. But after tests of a jet-powered Thunderbolt failed, it became clear that an entirely new kind of airplane was needed. In the Lockheed P-80 Shooting Star, the true power of the jet was revealed. As SAC's first jet fighter, the P-80's speed was electrifying, and within weeks, plans were underway for a jet bomber. By the end of the year, that bomber was ready. Built by Boeing, the B-47 showed the Air Force the tremendous speed and power offered by a large jet. But power had a price. The B-47 was also a gas guzzler. With its fuel-thirsty engines, the jet bomber's range was dramatically reduced. SAC's choices were slim. Either they opted for a slow long-range bomber, a fast short-range bomber, or they came up with a new way to feed the hungry jets. The solution was aerial refueling. Believing it to be a good way to utilize the old piston aircraft, SAC decided to convert their B-29s into tankers. The U.S. military had never used or tested aerial refueling techniques, but the British had, and it was their system that SAC eventually adopted. To enable the B-29s to act as refuelers, several changes had to be made to the aircraft structure. 2 large fuel tanks were sealed into the bomb bay. A reel of hose, 230 feet long, was placed in the rear of the plane, and the machinery to send it out and reel it in was installed nearby. For the system to work, the receiving plane also had to be outfitted with special gear. In temperatures as cold as 65 degrees below zero, high-octane fuel was transferred through the hose. Although the test was generally considered a success, there were still a few kinks to be worked out. The biggest drawback was that the system was rather complicated. In fact, not much had changed since the first barnstormers tried aerial refueling in the 1920s. Highly trained operators were required on both aircraft, and the pilots had their work cut out for them too. The planes had to be maneuvered into just the right position before the refueling could begin. Once they were lined up, the receiver operator wheeled out the receiving line. It had a special windsock attached to keep it from flailing about in the wind. In the tanker, the operator lowered another line, this one with a heavy weight on the end. Then the tanker pilot crossed over to actually entangle the 2 lines. That's how contact was made. At that point, the tanker held position while both lines were reeled in. After disentangling them, the tanker operator connected the receiver's line to the fuel hose, which was then pulled back by the receiver. Only after the receiver operator locked everything into place could the transfer of fuel finally begin. It was easy to see that the system had serious problems. Besides the fact that making contact between two planes was precarious at best, a high level of maneuvering was required from both pilots, a dangerous undertaking in turbulent conditions. Also, operators were required in both planes, ruling out the possibility of refueling single-seat fighter aircraft. For aerial refueling to be an effective part of military strategy, a better system was needed. The next arrangement the Americans tried was better, although not by much. Called the probe and drogue system, it involved the tanker aircraft reeling out its hose, or drogue, and the receiver pilot maneuvering his aircraft's probe into it. The most obvious benefits of this system were that it eliminated the need to entangle lines and that no operator was needed on the receiving plane. But the probe and drogue system had serious drawbacks. The biggest problem was speed. While the tankers were slow piston planes, the aircraft they refueled were fast jets. To maintain the same speed, the tanker had to fly as fast as it could go, while the jet had to slow down so much that it was constantly on the verge of stalling. As if that wasn't enough to deal with, the jet pilot also had to keep up with a drogue that flailed about erratically in the wind. Surprisingly, the Navy expressed interest. While they could see its drawbacks, the Navy's top priority was to find a system that was both light and easy to install on their carrier-based planes. The probe and drogue system had both of these things. The United States Air Force, however, pursued a different course. In the late 1940s, the Boeing company began developing an entirely new kind of refueling technique based on a rigid rather than flexible hose design. They called it the flying boom. One of the problems of the hose and drogue system that Boeing designers hoped their flying boom would overcome was the lack of stability in both planes after docking. Using a converted B-50 bomber as the tanker and the new B-47 jet bomber as the receiver, Boeing conducted their first tests without fuel. Not only did the flying boom work quickly and easily, but it actually helped stabilize both aircraft during the refueling process. Even in rough air, the rigidity of the boom kept their positions in check. Unfortunately, the speed problem that came with the combination of a piston tanker and a jet receiver were still there. In trying to keep its speed down, the jet bomber had to go through a routine of diving and climbing. It wasted an enormous amount of fuel and made the whole operation counterproductive. It was obvious that what was needed was a jet tanker, and in the mid-1950s, Boeing set to work on a design. The $16 million Dash 80, unveiled in the summer of 1954, remains one of the most legendary airplanes in history. With their early recognition of the piston tanker problem, and with the success of the B-47 bomber, Boeing used the Dash 80 to gamble on the future of the jet. The Dash 80 became the prototype for both the 707 and the KC-135, far exceeding the initial hopes of its designers. Eager to get a return on its investment and to satisfy the Air Force's urgent need for a jet tanker, Boeing rushed production on their brand new KC-135 Stratotanker. Just 2 years after the Dash 80 was revealed, the first jet-powered tanker was rolled out of the factory. As the KC-135 worked its way into the Air Force's fleet, aerial refueling became safer and more efficient. Capable of a top speed of more than 600 miles an hour, the Stratotanker had no trouble keeping up with the latest jet bombers or fighters. Boeing's jet tanker was an instant success, and the orders came pouring in. The arrival of the KC-135 revolutionized the operations of the Strategic Air Command. Capable of transferring 1,000 gallons a minute, the Stratotanker dramatically improved the intercontinental range and reliability of SAC's airplanes and strengthened the presence of American deterrence in the wake of a massive Soviet buildup. Their bombers now had the ability to be global attackers. In the KC-135, the world could finally see the true potential of aerial refueling. The development of the jet made all the difference.
And Tango, what are you guys doing? We're just entering base turn to follow. Okay, looking.
For the first time, the speeds of tanker and refueler were compatible. No one appreciated this more than the pilot of the receiver aircraft. Planes flying just above their stalling speed are sluggish, unresponsive, and extremely difficult to maneuver. Now, with the KC-135 steaming along overhead, all the receiver pilot needed to do was hold position and let the boom operator handle the rest. Although the flying boom system was well rehearsed by the time the KC-135 became operational, aerial refueling still had its risks. The two aircraft were required to fly in tight formation, just feet apart. Any unexpected turbulence or pilot error could bring the two jets crashing into each other. For planes in the Strategic Air Command, the risks are even higher. In 1966, an aerial refueling mission between a KC-135 and a B-52 ended in disaster. The two planes collided, leaving a trail of wreckage on the coast of Spain. The shattered remnants of the two planes paint a vivid picture of the cost of a mistake. But the aftermath could have been even worse. The B-52 had been carrying nuclear weapons. There are few pilots in the Air Force that don't face danger on a daily basis, but the risks faced by the crew of a tanker are anything but routine. The constant potential for calamity requires crews that are trained at the highest level, and much effort has been made by the Air Force to ensure that every crew member understands the importance of his job. Although the planes are certainly not the most glamorous the service has to offer, the role of the tanker couldn't be more important. Training to fly and operate a jet tanker is comprehensive and exhaustive. Lessons begin on the ground and require every student's undivided attention. While in the classroom, students learn the intricate details of the refueling process, as well as the nuances of operating a large jet. The long hours of training provide vital information on the aircraft's hardware and mission. Even when they're out of the classroom, these trainees are still a long way from boarding a tanker. The first thing a tanker student will fly is a simulator. While providing a safe environment for training, simulators allow students to experience every possible scenario that they might encounter on a real flight. Hurricane, wind shear, loss of power. The simulator can create it all. And the best part of all is that no multi-million-dollar aircraft ever gets damaged. Modern simulators have helped save the Air Force countless airplanes and lives by allowing crews to hone their skills in a realistic setting. Even on their first flight, their actions will have to be second nature. They'll need every ounce of concentration if something does go wrong. As members of the Strategic Air Command, this Stratotanker crew must be on alert at all times. The bombers aren't the only aircraft that could be called out at a moment's notice. Without the tankers, the rest of the fleet would be worthless. The increase in orders for jets within SAC made the KC-135 an even more valuable member of the fleet, as it provided support for both bombers and fighters. Surrounded by a star-studded cast, it's easy to overlook the stunning design of the KC-135. Powered by 4 mammoth turbojets and with wings swept back at 35 degrees, the Stratotanker combined power and speed in a giant body. It could carry 120,000 pounds of transfer fuel, far more than any other tanker of its time. Even fully loaded, the KC-135 had a range of more than 11,000 miles. In the heightened tension of the Cold War, Stratotankers provided the speed, power, and reliability SAC needed to make its fleet effective. The KC-135 was so effective, SAC enlisted it for other important missions. One of the primary concerns of the American military was its ability to command, control, and communicate with its forces in the event of a nuclear attack. They needed a fail-safe command and control center, a place that would not be affected by a catastrophe on the ground. They chose the KC-135. The Stratotanker's mission was called Looking Glass. Its job was to provide a mirror image of a ground-based nuclear command center. A KC-135, reconfigured and renamed EC-135, was given all the elements necessary to control American nuclear forces. An intricate computer network was placed inside the fuselage along with direct links to the nuclear arsenal. In the winter of 1961, An EC-135 Looking Glass left the ground, beginning one of the longest missions in military history. A Looking Glass aircraft, complete with a general on board, stayed in the air for 24 hours a day, 365 days a year, for more than 29 years. The mission didn't come to an end until the Soviet Union fell in 1991. Before 1960, few Americans were familiar with the wet terrain and harsh jungle climate of a small coastal country in Southeast Asia. Yet, within the next decade, almost 3 million Americans would serve in Vietnam. The influx of American troops and supplies from half a world away called on all the resources of the American military. It didn't take long for the KC-135 to emerge as an important partner in the operations in Vietnam. American involvement in Vietnam began as an advisory role, but as the North Vietnamese scored victory after victory, this position dissolved, and the United States became thoroughly entrenched in another country's civil war. As full-scale military operations were mounted, American aircraft and weaponry made their way to the front. Massive airstrikes began. The strategists hoped the result of the bombing would not only stop the Viet Cong's movement to the south, but also crush their resolve and force them to the negotiating table. American planes dropped more bombs on Vietnam than had been used in all the years of World War II. The KC-135 Stratotanker served as the Air Force's workhorse, but ironically, its need had been initially overlooked. As the bombing raids over the north began, the American military did not anticipate a need for aerial refueling. They had their brand new F-104s and F-105s, state-of-the-art jet fighters with more than enough range for the mission. But the range of the fighters was calculated on the basis that the aircraft would be able to cruise to and from their targets, using maximum power only in short bursts. The reality was quite different. Barraged by artillery and missiles from the ground, and the guns of the Russian-built fighters from the air, American fighters were forced into high-speed maneuvers for the majority of their missions. They gulped fuel at an amazing rate and significantly reduced their range. Without aerial refueling, the missions would have no chance of success. Before long, American pilots came to rely on the gas stations of the sky. The reliability of the Stratotanker gave fighters the ability to carry more weapons and to concentrate on their strike without concern for fuel. In what became standard procedure, KC-135s joined strike forces after their mission was carried out and refueled them on the way back to the base. The heavy use of jet fighters and bombers meant that the Stratotanker services were high in demand. During the war, tankers flew almost 200,000 refueling sorties and transferred 9 billion pounds of fuel. They also found other ways to help, sometimes even acting as flying tow trucks. Vietnam may be remembered by many as a helicopter war, but the service of the giant tankers was second to none. Since that war, the importance of aerial refueling has never been questioned. During the 1987 raid against Libya, the massive U.S. airlift during the Yom Kippur War, the British response in the Falklands, and more recently, the Gulf War bombardments by B-52s, modern air power has depended upon the steady and exceptional service of tankers. The military recognizes the integral role that aerial refueling plays in their success, and not surprisingly, the mission is far from over. Although the dependable KC-135 is still in service, it now has a successor. Based on the McDonnell Douglas DC-10 passenger jet, the KC-10 Extender is the first of the next generation of tankers. The Extender began service in 1981, and since then has performed magnificently in both war and peacetime.
Well, I don't know if that looks like a lot of work or not, but it is.
In addition to the standard fuel tanks found on DC-10s, the KC-10 has 4 additional fuel tanks inside the fuselage, giving it the ability to carry more than 350,000 pounds of fuel. That's almost twice as much as the KC-135.
About 100 feet right there. There's about 50 feet. I'm going ahead and give him the forward light now. He's clear to come in for contact.
The Extender also has both flying boom and hose and drogue equipment, so it can refuel both Air Force and Navy aircraft.
It's about 40 feet. That's 20 feet right there, right at the bottom of the wing screen. The boom's passing over right now. Once we get to the top of the windscreen, that'll be 10 feet. I'll start flashing the PDI lights. About 10 feet right there. There was we had a stick failure, flight control stick failure. We had to go ahead and back them out. Bringing them back in now. Try to do small corrections with the boom. About 5 feet from contact, I'll start extending slowly.
Representing a significant leap forward in design, the KC-10's boom operator controls refueling systems through a digital fly-by-wire system. It can even refuel at night. But in today's post-Cold War world, where funds for new military technology are hard to come by, a new emphasis has been placed on versatility. Aerial refuelers are no exception. Besides its tanker role, the KC-10 can also serve as a cargo and transport aircraft. It can even do both jobs at the same time. The Extender can transport up to 75 people and about 170,000 pounds of cargo. Plans are currently underway for a tanker that can take on even more roles. Derived from the Airbus A310-300 passenger jet, the MRTT, or multi-role tanker transport, would give versatility a whole new meaning. Not only would the MRTT be an exceptional tanker, but with minor reconfiguration, it could also be used for cargo lift, troop, passenger, or VIP transport, medical evacuation, or any possible combination of those roles. The importance of aerial refueling is such an integral component of military strategy that it's hard to imagine how air forces ever survived without it. The most high-tech, high-speed jets would be severely limited without the support of the giant tankers. Today's gas stations in the sky are a long way from Wesley May's first tests. Aerial refueling, once little more than a daredevil stunt, is now an indispensable part of military aviation.
Okay, looking. Slowly through the notch. Just see what's behind. And up. And that's what you got this. Okay, looking.